Hey y'all, the two problems in this video that I'm going to go over are going to use the formulas for projectile motion. The first problem says an object is punted at an initial velocity of 25.0 meters per second at an angle of 40 degrees above the horizontal. The first part of the question says what is the initial vertical velocity, and the second part says what is the initial horizontal velocity. Since my initial velocity is at an angle, I need to use my trig functions to break that down into an initial and horizontal component. So basically what this looks like is my initial velocity is at an angle of 40 degrees above the horizontal, and the magnitude of that is 25.0 meters per second. In order to find these two components, I'm going to use sine and cosine. Keep in mind that the VYI, the I stands for initial, the Y means the y-axis, so your vertical component, and V is velocity. For this one, you have VXI, I is initial, X as in the x-axis, so horizontal, and V for velocity. So this is your initial horizontal velocity. Your initial horizontal velocity is the same thing as your horizontal velocity. This does not change throughout the object's path because it is not being affected by anything. This velocity, your initial vertical velocity, does change over time because it is affected by the acceleration due to gravity. For the initial vertical velocity, now I'm going to say VYI equals the magnitude of your vector, so 25 meters per second, times sine. The reason that we're using sine for this one is because it is opposite of my angle that I'm using for the measure, and times the hypotenuse. Okay, so opposite over hypotenuse would be sine. When I put this in the calculator, I'm going to round that to 16.07, and that is meters per second. Almost the same thing with part B. The only difference is now I'm using cosine instead of sine. And that answer is 19.15 meters per second. Part C says which value for gravity should be used. Since this is in meters per second, I need to use the metric version for gravity, and that would be negative 9.81 meters per second squared. The next part says how long will it take the object to reach its max height? So there's something that you need to keep in mind with maximum height. Your Vy of t, which y stands for your y-axis, so your vertical velocity, and then of t just means at some point in time. So your Vy of t, your vertical velocity at max height, is going to be 0, because at that point it's like a parabola, right? We're talking about at this point right here, and at the very top of that, at its max height, whatever object you have that's following this trajectory is not moving up anymore, but it's also right before it starts moving downward. So there is no vertical velocity at max height. It's 0. That comes in handy because I can use that to help me find the time. If I know Vy of t is 0, I know the acceleration, and I know VYI because I just calculated that. Now I can use this formula to find t. Okay, I can't use this formula yet because I don't know y of t. I don't know how high it's going. I don't know what max height is, and I don't know t. Okay, this formula is irrelevant right now because I'm not finding anything out about the horizontal displacement. Okay, so the only option that I have is this one. I can't find this one because I'm missing 2 of the variables, y of t and t, but I can use this formula. So I'm going to copy that for part D, and then I'll fill in the blanks. So Vy of t equals AT plus VYI. Remember, we said the Vy of t, or your vertical velocity at max height, is 0, equals your acceleration, negative 9.81 meters per second squared, times your time. I don't know the time. That's what I'm trying to find out. How long will it take? Plus VYI, and that's this number up here that we calculated, 16.07 meters per second. Okay, from there I'm just going to solve for t. First, I need to subtract 16.07 meters per second from both sides. And now to get t by itself, I need to divide both sides by gravity. Divide both sides by negative 9.81 meters per second squared. When I do that, I end up with just t by itself on the right side. And over here, negative 16.07 divided by negative 9.81 is going to give me a time of 1.638 seconds. Now, I'm not rounding to sig figs yet because that's not my final answer. I'm going to need to use that value of t to find what the maximum height of the object is, which is what I'm trying to figure out in part E. Okay, now we're going to go back to our formula sheet, and if I'm trying to find max height, I need to use this y of t formula. Okay, y is your y-axis position at some point in time, and I'm finding it at max height. Okay, so remember, y of t is going to give you some kind of height. X of t is telling you how far it's going, like how far horizontally it's going or how far forward it's going. So I'm going to go ahead and copy this vertical displacement formula, and then I will plug in the things that I have for that. So y of t equals 1/2 AT squared plus VYI times t plus YI. Okay, and remember, this is what I'm solving for, so I know that everything over here is going to have some kind of value that I'm plugging in. This times t squared is the t that I just solved. Make sure that you square that. Okay, and yi is your initial y-axis position, or your initial height. Okay, but I'm punting this object and it's starting off at on the ground, so that would be 0 here. Then just plug this entire thing into the calculator. 1/2 times negative 9.81 times 1.638 squared plus 16.07 times 1.638. When you do that, your answer is 13.2. Oops, that should be an M. Meters. Okay, your meters per second squared cancels out with your seconds squared to leave you just meters. Okay, or if it's easier for you to see here, meters per second times second. So this second is on the bottom, this one's on the top. Those cancel and you're left with just meters. Okay, next question. A ball rolls off the edge of a table that is 1.15 meters above the floor and strikes the floor at a point 1.75 meters horizontally from the edge of the table. What is the initial vertical velocity? So this one's a little bit tricky because there is nothing about velocity in the question. However, if a ball is rolling off the edge of a table, that table is a horizontal surface. So initially, there is no vertical velocity. So initially, my vertical velocity is 0 because the ball is only rolling horizontally. There is no up or down movement while it's on the table. Part B says, what is the initial height? Well, it says the edge of the table is 1.15 meters above the floor. Okay, if you're looking ahead to your formula sheet and you want to figure out what these would be labeled as, you can do that at this point. So if you're talking about your initial height, remember the I's are initials and Y is going to be some kind of height. Y of T, Y of I, those are all heights. If it's YI, that's your initial height. So this would be YI. Part C says, what is the height of the ball at the time it hits the ground? Well, if the ball is on the ground, then that height is 0. Okay, that's the height at some point in time. Okay, that's your y-axis, and it's at some point in time because it's at the end. Okay, you can think of that as your YF, your final Y. Part D says which value for gravity is used. I have meters again, so I'm still going to use negative 9.81 meters per second squared. Part E is asking what is the forward displacement of the ball at the time it hits the floor. If you look back at the problem, it says it strikes the floor at a point 1.75 meters horizontally from the edge of the table. So that's how far forward it has gone, or how far horizontally it has gone. Remember, we were talking about this with the other problem. X of t is how far. So that would be your 1.75 meters, and that is x of t. Okay, now we're going to get into plugging this in. So part F says, what is the time the ball is in the air? So I know I'm solving for t. Let's see what formula we can use based off of what we have already. Okay, if I'm looking at this one, I know y of t. Okay, we said that was 0. I know acceleration because that's gravity. I don't know time. That's what I'm trying to find. Okay, what time is the ball in the air? I do know that my initial vertical velocity is 0. Okay, we didn't label that here, but this 0 is VYI. Remember, I initial, Y is vertical, V is velocity. So I do know that. I don't know t, but that's still the same variable that I was looking for. And then yi, I do know my yi, it's here. Okay, if you were gonna say, well, let's see if we could have used this one. Okay, this is your vertical velocity after some point in time. Okay, I don't know what the vertical velocity is at the moment that the ball hits the floor. The only time that this formula is going to be helpful is when you know that this value is 0, and that only happens when you are talking about something reaching a max height. Okay, and then this formula is not going to help me yet because I know how far, I know x of t, but I don't know the horizontal velocity and I don't know t. Okay, so I have to stick with this first formula. So I'm going to write that in first, and then we will plug it in. So y of t equals 1/2 at squared plus vyit plus yi. Okay, and I'm going to plug in those things that we know we have. I don't know t, so I need t squared there. Okay, this entire next term, this vyi times t, because vyi, my initial vertical velocity, is 0, anything times 0 is going to be 0. Okay, it doesn't matter that I don't know what t is, because whatever t is, when it gets multiplied by 0, it's going to be 0. Okay, and then plus yi, which we said was 1.15 meters. Okay, I'm going to move this over to the left side by subtracting it. So now I have negative 1.15 meters equals, I'm going to go ahead and put that in the calculator here, and that is negative 4.905 meters per second squared times t squared. Okay, trying to get t squared by itself first, and then I can take the square root of that. So now I'm going to divide both sides by this number. It's negative 4.905 meters per second squared. Okay, that cancels here. I'm left with t squared equals, when I put this in the calculator, it's about 0.23445 something. Okay, and that would be second squared because I'm doing the meters cancel out, and this is per second squared, but it's also on the bottom, so that flips it back to the top. And now I need to take the square root. And t equals 0.484 seconds. Part G is asking, what is the initial velocity of the ball? Okay, well, you might be thinking, oh, we already know the initial velocity is 0. But for this one, I am trying to figure out, I know the ball was moving, but how quickly was it moving? So in this instance, it's not asking me for the initial vertical velocity because it wasn't moving vertically. So I'm trying to find the initial horizontal velocity. Remember, your initial horizontal velocity and just your regular horizontal velocity are going to be the same thing. Nothing is acting against it. We're assuming that friction and air resistance and all of those things are negligible. And the only thing that would be acting on that velocity would be gravity, but gravity does not affect horizontal velocity because it only acts in the vertical component. Okay, so really what this question is asking is, what is the horizontal velocity of the ball? Okay, in order for me to figure that out, I need to use this formula because this is the only formula that has Vx in it. So I'm going to say x of t equals Vx times t. Now I can plug in those things. Okay, remember this is the how far, which we said was 1.75 meters, equals Vx is what I was trying to find, times t, which we just solved for. And the only thing that I have to do to figure out the velocity is divide both sides by 0.484 seconds. And you should get 3.62, and that unit is meters per second.